Yeah, I'm Muhammad Usman, and I'm working with at PSC for enabling BlueField DPU inside the OpenMP. And what is a DPU? So it is a network card, but it's not just it doesn't just deliver high speed. If it's 200, 400, 800 Gbps, that just makes it a high-speed network card. And there are a bunch of offloads in it. Like our processor cannot even, like last time I checked on Mare Nostrum, it could not even compose packets more than 40 at more than 40 Gbps rate. So we need RDMA offload, and there are more offload in a NIC like AES, IPsec, etc. But these offloads too just make them a SmartNIC. They don't make it a DPU either. What makes it a DPU is general purpose, somewhat high-performant cores, where user can deploy their own code and offload it on a DPU, just like we do it on the GPU. No, not with that level of performance, but to some extent, yeah. So, and one example of this is BlueField. And the way BlueField works is that it has a bunch of ARM cores inside it, and it runs its own operating system for now. And yeah, we call it the host separated mode. And generally, this is what HPC community is using. And yeah, we are trying to enable this in OpenMP, which is a challenge because of the different file systems and how decoupled both of these systems are. But let's talk about, the way we program this guy is with Doka API, and the shortest and cleanest introduction to Doka API is that Doka is for DPUs what CUDA is for GPUs. It is a little immature for now, but it works. But it requires a lot of knowledge about networks like UCX, FlexI, or DPA, DPDK. Yeah, we don't want users to do all of that. We want to integrate things into OpenMP, and yeah, let's see how that goes. So yeah, OpenMP. How many of people are here familiar with OpenMP? Wow, cool. Sorry, it would be just a little introduction. So yeah, in OpenMP, we can do multi-threading, basic stuff, add parallel, add for, and things would be just like would become multi-threaded. Just like this, we put as this thing, and it runs on all of the cores. With one line of code, we achieve multi-threading. And another feature is tasking. With tasking, we can make tasks, and they can run concurrently. So yeah, this line of code runs like these two blocks concurrently, and the output can be shown like this or this because they are running concurrently, and we cannot predict this particular system. And finally, we can use it for offloading as well. How many people are here using it for offloading? OpenMP for offloading? No, not yet? Oh, one guy, two guys, cool. So yeah, but generally, like offloading with GPUs is usual, but what we have done is that we have enabled it for DPUs. Well, this is how you do it. The regular code runs in the host, but if it is in OpenMP Target, this particular one runs in the device. Which device? We can mention a number that this particular ID, the device with this particular ID should get this particular block offloaded on. But how do we know which number, what device is that? That should be provided by the compiler. The compiler gives a utility, like this particular one from LLVM OMP device info, which gives information. And NVIDIA's GPUs have this. This one is Tesla VF100. There's a lot more to it, but it won't fit the screen. Yeah, that's how it works for GPUs. And how do we exchange data? Map to from, and data is exchanged. We don't need to do much by ourselves. The compiler does that for you. And yes, and how does it work internally? Like initially, the binary is loaded, and all the binaries that are required inside the code are just loaded at once. And then after, whenever the user has specified the data is submitted, the code runs, it is received back, and goes on. according to the user's requirements. Yeah, and how do we do it with DPU? Just by mentioning its number. It's so easy like that, and we have enabled this particular functionality inside the DPU already. Yep. And this is some info that the utility gives, which particular PCI is it connected on, and what is the message size, and how many message queues, blah, 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 is available inside the DPU. Yep, let's look at some code. So this particular piece of code, interestingly, this would not run on a GPU because GPU cannot run libc functions. But since the DPU is just a Linux system itself, it can run it. And as we can see, on right we have the host, and on left we have a DPU node. And the surface, first it was a print, so it is printing on the DPU side, which is on the accelerator, and then it's just an increment which does get increment on the DPU side, and then it returns back to B. We can do things concurrently as well using tasks. Like these two blocks are OpenMP tasks, and they can run concurrently on GPU and host and DPU. And yeah, just like this, these run in parallel. I could not show it to you today, but yeah, this is going and we can do the same with I/O. The I/O can be offloaded, and then the offloaded I/O can be pre-processed, or if you're going to send something pre-processed, or if you receive something, process it before receiving it. We think that would be the most major application that DPUs are enabling for now. What do we have besides that? Yeah, this is our team. Me, Sergio is in the room. Yeah, he's there. And then Antonio Pina. And yeah, we are looking for people, scientists whose applications we can collaborate with and accelerate on DPUs. Let's see how much capabilities do these devices enable in our applications. And I do the other way. Yeah, so yeah, we're actively hiring as well, and there are a bunch of events around heterogeneous memories, dynamic resource management, and Mare Nostrum Hackathon. I think Mare Nostrum Hackathon have same sponsors. Yeah. Yep, that's all. Do connect for accelerating your applications. Yep.
Much. Okay, questions? Okay. So so for those that haven't been involved in OpenMP development, so this is quite a big thing. So my experience from 4.2 and 5 implementation, it was great. And so before that, before having offloading capability inside OpenMP, you had to do something else, learning CUDA, learning OpenCL, or something like this. If you had your existing OpenMP code just offloading, you can get in return a lot of capability in there. So not sure. So we can now move, for example, to this forum discussion that we were talking before, and we can start with this topic that you just introduced, and we can carry on the next discussions that will turn. Okay. So how much OpenMP usage you see in your HPC facility? How much traction you see currently on GPU offloading in your OpenMP code? Okay, good.
So, no, do you want to start this discussion now, or you want to bring it to the later the forum? That's my point. I wanted to ask him one question about DPUs actually.
Please go ahead.
And maybe so I've seen that you focus on the OpenMP and you showed. I want to know if you are planning to use DPUs in a different approach, a different way, offloading services to DPU. So I know that when DPUs were introduced from NVIDIA, or earlier time from Mellanox, they were focusing on how we can try to offload as much as possible, which have been always their policy, to offload things to network interfaces, or for customized, or for DPU. For instance, on some calculation for file system, parallel file system, that you were just where it take place in the DPU. So do you plan to do such kind of work, or this is something out of the scope of the DPU for you?
We don't plan to do it ourselves, but we plan to collaborate with the people who are working on file systems or other applications to help them, enable them using, offload their services using OpenMP.
Okay.
Yep.
So yeah. Okay. So thank you.
Thank you.